net present value technique. This is one of the modern techniques of the capital budgeting. This method considers the time value of money, and this method uses a specific discount rate to bring all expected cash inflows into present values, so that whatever it is expecting, whatever firm is expecting cash inflows, it should be more than the investment. If it is more, it has positive NPV. If it is less than the investment, those are nothing but present value of cash outflows. If it is less than the outflows, it is negative NPV, which is not suggestible. So, determining the discount rate. Theoretically, the discount rate or desired rate of return on an investment is the rate of return the firm would have earned by investing the same funds in the best available alternative investment. In the sense, if firm uses the same funds in other best alternative, how much they will get? That should earn by this project. Say for example, if you deposit 1 lakh rupees in a bank, you will get 7% or 5%. Say for example, 5% interest in an year. After completion of year, you will get 5% of interest. If you start a business by investing that 1 lakh rupees, so if you are able to earn only 4%, then what is the use of it? So the best return is 5%. If you deposit, you will get 5%. What is the use of doing business? Right? So if you invest same funds in the best alternative, whatever return you are earning, that is the rate of return of the firm. And determining the best alternative opportunity available is difficult in practical terms. So rather that using the true opportunity cost, organizations often use an alternative measure of the desired rate of return. So it is very difficult to determine the alternative opportunity. In the same example, I just compared with the bank deposit. So it is not comparable. There are some other sources which gives more return than this. So it is very difficult to find such kind of alternatives. So that is why firms often use alternative measure for the desired rate of return. An organization may establish a minimum rate of return that all capital projects must meet. This minimum could be based on an industry average or the cost of other investment opportunities. Many organizations choose to use overall cost of capital or weighted average cost of capital. So that is why the discount rate or desired rate of return, it also be called as minimum rate of return, cost of capital, weighted average cost of capital. Okay, so we can use any name, so that an organization has incurred in raising funds or expects to incur in raising the funds needed for an investment. So in both ways it may use. So the net present value of a project is the amount which is more than the outflows, the amount of expected cash inflows, present value of expected cash inflows should be more than the present value of cash outflows. So NPV is nothing but present value of cash inflows minus present value of cash outflows. Cash outflows are nothing but investments. Okay. See why we have to use the present value in front of the cash flows instead of using the investment. We can use it, but in the middle of the project, in some projects, in the middle of the project, so additional working capital may required. So additional repairing cost may incurred. In such a cases, those costs also, those working capital also, we need to bring it into present values. So it is better to use present value of cash outflow. Okay. So the steps to calculating the net present value. So I already gave the formula, present value of cash inflows minus present value of cash outflows. So how to determine the net cash inflows? So we have to consider the profit before depreciation and tax. So from that you have to deduct the depreciation, and again you have to calculate the tax, and you have to deduct the tax. Again you have to add the depreciation, so that you will get the final net cash inflows. So that is the determination of net cash inflows. So we have to determine the net cash inflows in each year of investment. Second one, select the desired rate of return. That is nothing but cost of capital or weighted average cost of capital or minimum rate of return. And find the discount factor for each year based on the desired rate of return. So by using the desired rate of return, the cost of capital, we have to find the discount factor in the discount factor table, present value factor table, and then you have to multiply with the discount factor to the cash inflows. So decision rule, if NPV is greater than or equal to 0, accept the proposal. It depends on the proposal. Accept the proposal. If NPV is less than or equal to 0, then reject the proposal. Less than in the sense outflows are more, inflows are less. So it becomes negative. So positive in the sense inflows are high and outflows are low. So then you can accept the proposal. What if NPV is 0? You may reject or you may accept the proposal. So what are the advantages of the net present value method? So it considers the time value of money, and the whole stream of cash flows is considered. The net present value can be seen as addition to the wealth of the shareholders, and NPV uses the discounted cash flows. NPVs of different projects therefore can be compared. It implies that each project can be evaluated independent of others on its own merit. Limitations, it involves difficult calculations, and the other one is the application of this method. Please be careful about this point. The application of this method necessitates forecasting cash flows and discount rate. It means This NPV totally depends on the accurate estimation of these two factors. So we are estimating the cash inflows. We are estimating those cash inflows. So future is always uncertain, but we are estimating by considering the all factors from marketing, production department, and various other departments. Okay, and we are estimating the discount rate as well by considering the cost of capital of other opportunities. Likewise, so it depends on the accurate estimation. That is the limitation. So the decision under NPV method is based on absolute measure. It ignores the difference in initial outflows. If two projects have different outflows, say for example, if one project has the 1 lakh outflow, 1 lakh investment, another project requires 2 lakhs investment, how can you compare with these two projects? Which one is best? How can you compare? Because two projects have the different outflows, different investments, and size of the proposal as well, while evaluating the mutually exclusive projects. So this is also one of the limitation of the net present value method. So let us go with the illustration 1. So illustration 1, compute the net present value for a project with a net investment of 1 lakh rupees and yearly net cash flows are 55,000, 80,000 and 15,000. Further, the company's cost of capital is 10%. So present value of interest factor at the rate of 10% for 3 years. So there is no need to search in the present value table. It is already given in the illustration itself. Okay, solution. So if we prepare the table, it is very easy to calculate the net present value without any misses. So year 0, from year 0 I am starting it, and the life of the project is 3 years because we have returns for 3 years. Okay, so in the year 0 we invested 1 lakh rupees, and present value of this 1 lakh. So in the year 0 present value of interest factor will be 1 only. Okay, so it becomes 1 lakh. So now we are calculating the present value of inflows. So inflows are 55,000, 80,000 and 15,000. Present value factors are 0.909, 0.826, 0.751. So we have to multiply this cash flows with the present value of interest factor. So amounts will be 49,995 and 66,080 and 11,265. So we have to combine the inflows and we have to deduct the outflow. So here in this case inflows are more than the outflow 1 lakh rupees. So net present value, therefore NPV is equal to 27,340. So now recommendation. recommendation, since the NPV is positive, the company should accept project. So this is what the procedure we have to apply to calculate the net present value. Now illustration 2. ABC Limited capital budget is limited to 5 lakhs rupees. Cost of capital or minimum rate of return or required rate of return, that is 12%. Projected net cash flows for each project are shown below. You are required to compute the net present value of the different projects. We have 4 different projects here, and this is the initial investment, and in project A we have uniform cash inflows, and in the other projects cash inflows are not in uniform. Okay, let us try to compute the net present value. So we have to prepare a table, period, present value factor, project A, project B, C and D. So period, for the initial investment year 0, and for the remaining 1 to 5 years. So present value factor, so cost of capital is same for the all projects. That is why I am taking present value factor in the second column. So in the year 1, present value factor is 1. So investments, after converting investment into present value, if you multiply with the present value factor, so the values will be the same. So present value factors for the year 1, 2, 3, 4, 5. Okay, this one is future value. So present value interest factor of 1 rupee. So cost of capital is 12%. Cost of capital 12%. So these are the present values at 12%. In the year 1, it is 0.893 and 0.797. So these are the present value factors up to 5 years. And now we have to multiply this present value factor with the inflows, cash inflows each year in the respective years. So 0.893 into 50,000 in project B, 0.893 into 40,000 in project B, and with 75,000 in project C, and with 75,000 in the project D. Likewise, we have to calculate the, we have to convert the cash inflows into present values. If you do observe in project A, cash inflows are uniform. So we can choose present value of annuity factor in the year 5. So that annuity factor is 3.6, one second, 3.605, 3.605, or you can combine all these present value of interest factors for 5 years, you will get the same amount, that is 3.605. So I'm multiplying directly 3.605 into 50,000. So it comes around 1,80,250. 1,80,250. So PV of inflows are less than the outflows. So net present value, therefore NPV is equal to NPV for project A, it has minus, negative. So 19,750 in negative. So in project B, if you multiply the inflows with the present value of interest factors, so the values will be like this, and the net present value is 25,635 positive. Actually, I calculated all these things. So for the project C, it has positive NPV, that is 27,050 rupees, and for project D, it has negative NPV because outflows are more than the inflows. So with this, you can able to suggest your recommendation for the project B and C. Both are having positive NPV. So the remaining project A and D are negative NPV. So it is suggested that project B and C are to be selected. So recommendation is project B and C should be selected. Now, profitability index. This is also one of the modern techniques of the capital budgeting. It is also called as desirability factor or present value index method. In the above illustration, the students may have seen how, with the help of discounted cash flow technique, The two alternative proposals for capital expenditure can be compared. In certain cases, we have to compare a number of proposals, each involving different amount of cash inflows. So one of the methods of comparing such proposal is to work out what is known as desirability factor. So that is nothing but profitability index. So the desirability factor is calculated the sum of discounted cash inflows divided by initial cash outflow or total discounted cash outflow. So in simple terms, PV of cash inflows by PV of cash outflows. So decision rule for this profitability index is, if profitability index is greater than 1, accept the greater than or equal to 1, accept the proposal. If profitability index is less than or equal to 1, reject the proposal. If it is equal, you may accept or reject. That depends on the decision making of a management. So what are the advantages and limitations of the profitability index? Advantages: the method also uses the concept of time value of money. Limitations: as a guide, it fails as a guide in resolving capital rationing. So what is capital rationing? If you have 100 crores, so how you are going to invest those 100 crores in different projects? So that is the different concept. On what basis you invest in different proposals? So how much you invest, that depends on the project investment capacity. So once a single large project with a high NPV is selected, possibility of accepting several small projects which together may have higher NPV than single project is excluded. See, if combinedly all together projects may have higher NPV, situations may arise like in some cases profitability index is lower. Even though it is lower, it is being selected because of NPV. So situations may arise like that. So instead of selecting one, it is better to select the several projects together which may have the higher NPV. So I am explaining this profitability index with the example. Suppose we have 3 projects involving discounted cash outflows 5,50,000, 75,000 and 1 crore 20,000 respectively. These are the outflows, cash outflows. Suppose further that the sum of discounted cash inflows for these 3 projects are 6,50,000, 95,000 and 1 crore 30,000 respectively. Calculate the desirability factor for the 3 projects. So projects 1, 2, 3. This is the explanation. PV of inflows. So discounted cash flows given. So present value of cash inflows divided by present value of cash outflows. So that how much portion it has in the returns, how much portion of investment. So that is nothing but 1.18 times. So 1.27. So 1.001. Here the amounts are bigger, but the difference is only 001. So it would be seen that an absolute items project 3 gives the highest cash flows, at its desirability factor is low. See, the desirability factor is low, but if you compare with the other projects, it has highest cash inflows. This is because the outflow is very high. The desirability or profitability index factor helps us in ranking various projects. So this is how we have to apply the procedure in determining the profitability index.